Dear participants, I welcome all of you in this lecture of Advanced Libraries, in which I will discuss Scikit-learn. And in last class, we discussed histogram plot and how to draw histogram using matplotlib and seaborn. Then we discussed bar plot, kernel density estimation curve, box and whisker plots, joint plot, volume plot, correlation matrix plot, scatter plot, pair plot. So we discussed, several different types of plots. Some plots were univariate plot, and some were multivariate plot that we have seen in last class. In current class, we'll discuss Scikit-learn. It is also known as Sklearn. We'll discuss basics of Sklearn. We'll discuss certain properties of Sklearn. Sklearn functionalities for the following. So, for each stage of data science, Sklearn provide different functionalities, like be the stage of dataset loading, splitting the dataset, preprocessing, model execution, model evaluation. So, at every stage, Sklearn provides several functionalities that we can utilize. So, what is Scikit-learn, or you could say Sklearn? So, Sklearn is an important library for machine learning in Python. It is a very important library, for whole data science implementation. And the beauty with Scikit-learn is it is having methods and functionality at each stage of data science, whether it is dataset loading and dataset partition, pre-processing, and several type of models are there. And similarly, there are several performance matrices that come under Scikit-learn. So, it is an open source library that offers an extensive suite of both supervised and unsupervised learning algorithm. So, it supports both supervised as well as unsupervised learning algorithms. So, the library includes a variety of efficient modules and packages designed for machine learning and statistical modeling. So, it has several modules and packages that we can utilize for implementation of machine learning specific problem, or you could say data science specific problems. There are certain properties of Sklearn. So, some of the important features provided by Sklearn are as follows. It actually supports supervised learning algorithms. So, almost all the popular supervised learning algorithms like linear regression, support vector machine, decision tree, and there are several more actually. So, all the different type of algorithms can be implemented using Sklearn. As far as unsupervised learning is concerned, so it also supports popular unsupervised learning algorithm. So, from clustering, factor analysis, principal component analysis to unsupervised neural networks. So, it supports all these algorithms. It has also support for cross validation. So, it used to check the accuracy of supervised model on unseen data. So, cross validation is used to check the accuracy of supervised model on unseen data. So, it has support for cross validation as well. Then dimensionality reduction. So, it means if we are having in our data set, if we are having several features, and if you want to reduce the feature, that we call dimensionality reduction. So, Sklearn also support dimensionality reduction. Similarly, Sklearn supports ensemble methods as well. It is used, actually ensemble method is used to combine several models such as ADA boost, gradient boosting. So, these are ensemble methods that we can implement using Sklearn. Similarly, we are having a method for feature selection as well. So, it is used to identify useful attributes to create supervised models. So, it supports feature selection as well. Pre-processing, so we are having different components under pre-processing. So that is actually supported by Sklearn. Similarly, model execution and evaluation. So you can evaluate your model using several performance matrices through Sklearn. So all these are actually supported by the Sklearn. So you can imagine the importance of Sklearn. Now, these are certain stages of data science specific problem. I mean, the solution, if you need to have proper solution for a data science specific problem, then we can follow these stages, So the stages are dataset loading, splitting the dataset, visualizing dataset, that is that comes under descriptive statistics, then pre-processing the data, train the model using certain models, or you could say algorithms, and then model evaluation. So these are certain stages of the data science specific solution. I mean, data science specific project. So suppose if you are having any problem related to data science and machine learning, so you would follow these stages, and for each and every stage, Sklearn has support for that. So as far as data set loading is concerned, so it has following two components. So every data set is having two components, that is that we call features and response. So what are features? So the variables of data are called its features, that is independent variables, right? So all these are called features. They are also identified as predictors, inputs, or attributes. So we can call it attributes, input, and so on. Response, it is the output variable, that is dependent variable, you could say dependent feature variable. They are also known as target, label, or output. So when we are loading the data sets, once it has been loaded, the next task is to partition feature and response. You could say the independent variables and dependent variables. So Sklearn has support for dataset loading as well. Sklearn itself provides several type of toy dataset, you could say, and like in this case, it is having a support for Iris dataset. Iris dataset is very popular data set as far as initial level of machine learning is concerned. So Iris dataset consists of three different types of irises: Setosa and Versicolor and Virginica, and it contains petal and sepal length and width as independent variables, which are stored in a 150 cross 4 NumPy array. So 150 cross 4, it means it is having 150 records and 4 independent variables. And what are 4 independent variables? These are sepal length and sepal width, similarly petal length and petal width. And the dependent variable is actually 3 different types of irises. So you can import these data set using this particular import command. Similarly, using this particular module sklearn.datasets. It also supports different other type of data sets such as Boston horse prices and diabetes as well, and so on. So it has support for digits as well, digit data set as well. So we can load data set in this manner. So here Sklearn is being utilized. Now the next stage of dataset is dataset specific project is splitting the dataset. So to check the accuracy of your model, you need to split the dataset into 2 different pieces. That is a training set and a testing set. So we use the training set to train the model and testing set to test the model. So using the training set, we will train the model, and once model has been trained, we will test the performance of model using the testing data sets. So that is the task we used to perform. So for splitting the data set, Sklearn has support for that. So what we need to import? So we need to import train test split modules that comes under sklearn.module selection, right? And it has this particular method where we are passing the actual independent features, independent variables, and this is the dependent variable. And then we are using test size as 0.2. It means the training size would be 80%. So the size of training data, or you could say training record, would be 80%, and test record would be 20%. So we would reserve 20% of record as a test size. Then we are having one more parameter, that is random state is equal to 42. So you could use any value here. It is actually used to guarantee that the split will always be the same. It means actually we are passing this seed value in random generation algorithm that actually return the same set of records. So using this initial seed value, we can guarantee that the split will always be the same. You can utilize any value here, right? So let's say you could use 10 and so on. And the beauty with this value, seed value, is that you can regenerate your you could say training and testing data set. Now come to the pre-processing. So it also has several type of pre-processing activities. I mean, Sklearn has support for different type of pre-processing activities. The very first that we'll discuss here, dimensionality reduction. So it may be useful to reduce features if number of features is high in your data set. So let's say you are in your data set, the data is very high, right? So in this case, you can utilize the functionality of Sklearn. So actually the dimensionality reduction refers to the process of reducing the number of variables in a data set. When dealing with high dimensionality, high dimensional data, that we also known as the curse of dimensionality, this process becomes essential when you are having large number of independent variables. The most common techniques that are used in dimensionality reduction are principal component analysis that we are using here. Sorry. So let me select the pen tab here. Yes. So the principal component analysis, actually this technique identifies the axis that accounts for the largest amount of variance in the training data, and also define the second axis orthogonal to the first one, and so on. So this is the working of principal component analysis. Apart from principal component analysis, there are certain other dimensionality reduction methods such as linear discriminant analysis and T-distributed stochastic neighbor embedding that we call T-SNE. So there are certain different methods. So how can we use dimensionality reduction using Sklearn? So first we need to import PCA, and here actually we are using component as 3. It means we are trying to fetch 3 features in this case, and then you need to use fit transform method in this way, and this x underscore PCA would actually contain the reduce independent variables. Next, we'll discuss in improved processing to converting categorical data into numeric values. So categorical data that we say in case of in last class we were discussing about a particular type of data set, that is crop recommendation data set. So in crop recommendation dataset, there is a one dependent variable, that is label, and that label is having categorical data, right? Like rice and chickpea and so on. So there are different type of crops. So these are categorical data. And suppose there are certain more categorical data in your data set, and especially in independent variables. And if you want to convert this categorical data into numerical data, then we can have different type of methods inside Sklearn. So categorical data of your dataset can be converted into numeric values using the ordinal encoder. And why there is a need of actually converting categorical data into numeric? Because several machine learning algorithms works very well in numerical data, based on numerical data, like KNN and so on. So for those type of algorithm, we should convert categorical data into numerical values. So the very first approach that we will discussing is ordinal encoder. So what ordinal encoder does, it actually read the categorical data, and it accordingly it assigns certain numeric value. So let's say 0, 1, 2, 3 and so on, right? Like ocean proximity is having that we have already seen. Ocean proximity is having 5 different categories, right? So it would assign values as 0, 1, 2, 3, 4 in this manner. So ordinal encoder would assign the value in this manner. And how to use? So first you need to import ordinal encoder, and then you need to mention which variable is actually the categorical data. So this one is the categorical data, and we need to use fit transform. So it would actually return the numeric value, and then we'll finally what we'll do, we'll drop the actual actual column, or you could say actual variable or feature. So we'll drop this feature, and then we will add new feature with the numeric value. So here this feature has been added. So first it has been dropped here in this stage, and then it has been added here. So in this way, the categorical data, the feature having categorical data has been dropped, and the feature with the numeric value has been added into the data frame. So that is the way of doing performing ordinal encoder. Now there are certain other encoder as well, like one hot encoder and several other. So apart from ordinal encoder, we are having certain other encoder as well, like one hot encoder in which actually what is the problem with ordinal encoder? It actually establishes the relationship between these values, right? So several algorithms identify that these are near to each other. I mean, there is the data is very near to 0 and 1. Similarly, 1 is near to 2. But actually, when we are converting from categorical data to numeric value, in that categorical data, there is no such relationship between the different categories, right? So if we are converting using ordinal encoder, so actually it is establishing a relationship. So the model would identify that these two are nearer to each other as compared to these two. So 2 and 3 is nearer to each other, while 2 and 4 is far as compared to 2 and 3. So this actually this type of information would be actually somehow not right as far as machine learning models are concerned. So for that purpose, there are certain other encoder, like one hot encoder. What it does, it actually create different features. Let's say you are in your categorical data, you are having 5 different categories, right? So internally it would create 5 different variables. Let's say x1, x2, x3 and x4 and x5, and these are different categories actually. So the category which is true, I mean the in a particular record, for that category it would assign 1, and rest of the variables would have 0 values where the x1 is true. Similarly, for the category x2, all would remain 0 except x2. So in this manner it would assign the values. So this is another way of performing the converting the categorical data into numerical values. Now we'll discuss feature scaling. That is one that also come under pre-processing strategy. So machine learning models may struggle with input features that vary in scale, right? So vary in scale, it means several features are the features which are there in your data set are having different scales. So to address this, 2 popular methods are used to normalize the scales, and that we call mean max scaling and standardization. So what is mean max scaling? That is minimum and maximum scaling. It often referred to as normalization, is a straightforward approach where the data is adjusted to fit within a 0 to 1 range. In min max scaling, where we feed the data between 0 to 1. So this adjustment is actually done by subtracting the minimum value of the feature and then dividing by the range. So that is maximum value minus the minimum value. And in case of standardization, it actually differs from min max scaling in a way that this actually involves subtracting the mean from each feature value and then dividing by the standard deviation. So this is the process of standardization. And how to perform feature scaling? So for that, if you are following standard scalar, then we need to import this standard scalar which is there in Sklearn.preprocessing, and we'll create one object here and we'll try to fit the existing value, I mean existing independent variables. Then that would be transformed to the standard scale, right? So this would give you a standard scale on the basis of a standard scalar. So there is another way as well, that we were talking about, that is mean max scalar. So mean max scalar would scale your data between 0 to 1. So in this way we can utilize feature scaling as well. Now the next stage is, after pre-processing, the next stage is train the model. And for training the models, Sklearn has support for that. So now the data set can be used to train some prediction model. So the next strategy is to train the model. As discussed, Scikit-learn has wide range of machine learning algorithms such as KNN, random forest, linear regression and so on, and logarithmic regression and so on. So there are several methods that you can apply. Here you can apply ensemble models as well, AdaBoost and so on. So there are several ensemble models as well. We can also combine core models to make your own ensemble machine learning models. So how to execute different models? So suppose you are interested in KNN. We'll discuss, when we will be discussing the machine learning models. So in separate classes, we'll discuss, KNN and then linear regression and so on. So this class is actually specific to Sklearn, where actually I want to show that Sklearn has support for different stages of data science specific project. So the target of this class is to discuss Sklearn. And in separate class, we will discuss pre-processing activities as well. And under pre-processing, we will discuss how to perform missing values, and how to perform class imbalance problem and so on. So we will discuss in a separate class, but this class is actually meant for Sklearn specific functionality. So whatever the model that you want to use, first you need to import that model, and this KNN is actually inside sklearn.neighbors. So first you need to create the object, or you could say handler, and then you need to fit your training data set, where you need to specify what is your xtrain. Xtrain, it means the independent variables, and this ytrain is your dependent variable. So first you need to train the model. So this is the statement for training the model. Next, you want to predict the value. So utilizing the testing data set. So this is your predicted value based on your model. Similarly, you can in the same manner you can execute decision tree as well. So this decision tree is actually inside the sklearn.tree. So inside this package you will find decision tree classifier. Then the rest of the approaches are very similar to KNN that we had seen. Similarly, you can execute a different type of models. Now the last stage that we'll discuss here, that is model evaluation. You want to check the performance of your model. So for that purpose, you are having different type of matrices like precision score, accuracy, F1, recall, RC curve, confusion matrix. So all these you can have a performance model as far as classification is concerned, right? So what is actually accuracy? So this is the most important performance measure, and it is simply ratio of correctly predicted observation to the total observation. So in your total observation, you are having true positive, true negative, false positive, false negative. So in this way you can calculate the precision score, accuracy. And as far as precision is concerned, so precision is the ratio of correctly predicted positive observation to the total predicted positive observation. And then we are having several other performance like recall, which is actually the ratio of correctly predicted positive observation to the all observation in actual class. So, and similarly, you are having another. And what about confusion matrix, which is very important? Confusion matrix is actually a table showing correct predictions and type of incorrect predictions. So, confusion, we can utilize confusion matrix. And similarly, there is one more model, that is confusion matrix display, that will be used to display the confusion matrix in an interactive manner. So this way we can use precision score and then accuracy score. So what it needs, this method needs actually the dependent test data set and the predicted value. So based on your model. Similarly, for accuracy score, you need to have white test and the predicted value. So this is the actual value that is there in your data set, and this is the value that your model has predicted. So in this way, you can check the performance. Similarly, you are having confusion matrix, and then in confusion matrix, you can also utilize confusion matrix to plot the a matrix, which is very interactive matrix that we had seen in we'll also discuss confusion matrix when we will be implementing models. So now let me switch to the Google Colab, where I will try to show you how we can implement different stages of data science specific project. So here, I'm trying to mount my drive, and then I will try to read a certain data set that is there in my drive. So it is trying to mount the drive right now. So it is executing here. Now I need to provide access. Actually, I need to grant access to access my Google Drive. I need to grant permission to access my Google Drive. So finally, my drive has been mounted here. Now, here I was talking about loading a data set. This is a ARIS data set that is a very small data set having 150 records, right? And this is actually the independent variables, and this one is the dependent variable, right? So dependent variable, it means it is having 3 different values depending on the type of iris, and X is having different values as far related to 4 different independent variables, that is petal length, petal width, and so on. So let me execute this one. So you can see here I have printed the dependent variable, which is giving me 0, 1, and 2. So there are 3 categories of iris. That's why it is coming as 0, 1, 2, 3. Now here I am trying to read the diabetes data set, and right. So this is the code for to find the principal component analysis that is dimensionality reduction process. So here I have used n component is equal to 3, and then I am trying to fit my independent variables. Now you could see here, since I have given n component is equal to 3, now the independent variables have been modified in this manner. It is having 3, the dimensionality reduced data set is having 3 independent variables, or you could say 3 independent features. So in this way it actually works, principal component analysis. Similarly, let me delete this one. And yes, this is the way of converting, splitting the data set. I am splitting the data set, so I can increase the size as well. So 3, it means I am giving here 3. It means I am reserving 70% of my training data set and 30% for testing data set. And you can utilize random state as 20 and so on. Any value you can provide here, right? So let it be 42, and so you can see here. Sorry. So first I need to actually explain info. Sorry, this is not info. Yes. It is actually NumPy array, extrain extract, and NumPy array is not having any info method. Info method is actually inside the data frame. So this is the value of extrain and extract and so on. So in this way, so this is the confusion matrix actually. So it is the value having true label as 0 and 1, and these are the predicted value. So true, it actually give you several type of true positive, it is having true positive as 37, and true negative, it is having 78, and so on. So in this way you can print confusion matrix. We will discuss confusion matrix in separate class actually. Now you can see here I am trying to train the model based on logistic regression, right? So I'm creating an object of logistic regression, and then I will fit my model based on training data set. So here it would actually train the model, and then finally the uh, predicted value would be calculated in this manner. So log underscore r underscore predict would actually contain the predicted value. Yes. And to calculate precision score, so we need to use precision score where you need to pass. So in each and every performance matrices, you actually need to pass test data. It means test data of dependent variable and the predicted value, right? Predicted value. So these two you need to pass in this case. Now let me switch to the PPT now. So I'm summarizing today's lecture. So we had seen the basics of Sklearn, and it is one of the most important library of data science. We discussed certain properties of Sklearn as well, and we had seen Sklearn functionality as far as dataset loading is concerned, splitting the dataset, pre-processing, model execution, and model evaluation. So at each and every stage, Sklearn has different methods. Now I am stopping here, and we'll meet again in next class. Thank you so much for joining the lecture.